All right, here we are with lesson 6, graphs of linear functions and rate of change. So let's do the opening exercise. On your lesson worksheet, you have functions 1, 2, and 3 that have tables shown below. Examine each of them, make a conjecture about which will be linear, and justify your claim. We will come back to your conjecture later in the lesson. Continue the video when you are finished answering the question. Okay, you should have finished answering the question on the lesson worksheet for the opening exercise. Let's go ahead and continue the lesson. So in this discussion, again, take notes as you need to in your journal. Let's review what we learned in the last lesson. The graph of a function is a set of ordered pairs of inputs and their corresponding outputs. The graph of a function is identical to the graph of the equation or formula that describes it. Recall what we know about rate of change and slope. So you might want to look back into your Unit 4 information about rate of change and slope. Now, write a claim about what you think the graph of a linear function will look like. You need to support your claim with some mention of rate of change or slope. So suppose a function can be described by an equation in the form of y equals m times x plus b, and that the function assigns the values shown in the table below. So here is our table. We want to determine whether or not this is a linear function, and if so, we want to determine what the linear equation is that describes the function. In Module 4, or Unit 4, we learned that the graph of a linear equation is a line, and that any line is a graph of a linear equation. So one begets the other. Therefore, we can show that a linear equation produces the same results as a function. Then we know that the function is a linear function. How did we compute the slope of a line, or slope of the graph of a line? Well, to compute slope, we found the difference in the y values compared to the distance in x values. We used the following formula. M is equal to the change in y1 to y2 over the change in x1 to x2. Based on what we learned in the last lesson about graphs of functions, that is, the input and corresponding output can be expressed as an ordered pair, we can look at the formula as the following. M is equal to output sub 1 minus output sub 2 over input sub 1 minus input sub 2. If the rate of change, that is slope, is the same for each pair of inputs and outputs, then we know we are looking at a linear function. To that end, we begin with the first two rows of the table. So the change in 5 to 8, which is a -3, over the change in the y coordinate, or the x coordinates, 2 to 3.5, is a -1.5. So the difference, or the ratio between the two of those, -3 divided by -1.5, is 2. So calculate the rate of change between rows 2 and 3 and rows 3 and 4. So again, the difference between the y values and the x values leads us to 2 again. And with the next row, the difference in x values over the difference in y values is 2. So what do you notice? Well, the rate of change between each pair of inputs and outputs was 2. To be thorough, we could also look at rows 1 and 3 and 1 and 4. There are many combinations to inspect. What do you think the result will be? Well, we should expect the rate of change to be 2. Go ahead and verify our claim by checking one more point. Stop the video and then continue when you are done. Alright, so you should have come up with the same thing. With this knowledge, we have answered the first question because the rate of change is equal to a constant, in this case 2, between pairs of inputs and their corresponding outputs. Then we know we have a linear function. Next, we find the equation that describes the function. At this point, we expect the equation to be described by y equals 2x plus b because we know the slope is 2. Since the function assigns 5 to 2, 8 to 3.5, etc., we can use that information to determine the value of b by solving the following equation. In this case, we're going to use the assignment of 5 to 2. That means 5 is equal to 2 times 2 plus b, which when we solve for that, b is equal to 1. Now we know that b is equal to 1, we can substitute into y equals 2x plus b, which results in the equation y equals 2x plus 1. The equation that describes this function is y equals 2 times x plus 1, and the function is a linear function. What would the graph of this function look like? Well, it would be a line because the rule that describes a function in the form of y equals mx plus b are equations known to graph as lines. We've already proven that in the past. The following table represents the outputs that a function would assign to given inputs. We want to know if the function is a linear function and, if so, what linear equation describes this function. So how should we begin? Again, we need to inspect the rate of change between pairs of inputs and their corresponding outputs. You need to compare at least 3 pairs of inputs and their corresponding outputs to make sure that nothing changes within the table. Go ahead and stop the video and pick your pairs of inputs and outputs, and then continue the video when you are done. All right. You might have picked different inputs and outputs than the ones given here, but you should have noticed that the rate of change is different for each pair of inputs and outputs. So, what do you notice about the rate of change, and what does this mean about the function? The rate of change was different for each pair of inputs and outputs inspected, which means that it is not a linear function. If this were a linear function, what would we expect to see? Well, if this were a linear function, each inspection of the rate of change would result in the same number, similar to what we saw in the last problem, in which the result was 2. We have enough evidence to conclude that this function is not a linear function. Would the graph of this function be a line? Well, no, the graph of this function would not be a line. Only linear functions whose equations are in the form of y equals m times x plus b graph as lines. Since this function does not have a constant rate of change, it will not graph as a line. All right, here we go on our first exercise. Complete the exercise on the lesson worksheet, then continue the video to check your answers. All right, you should be done with the exercise. Here are the answers. Now again, you can check at least 3 pairs of inputs and outputs for part A. You might not have picked these 3, but you should have noticed that the rate of change is constant, which is a -3. All right. So going back to the opening exercise, and verify whether your conjecture was correct based on what we've learned in this lesson. And to wrap up, we know that if the rate of change for pairs of inputs and corresponding outputs is the same for each pair, the function is a linear function. We know that we can write linear equations in the form of y equals m times x plus b to express a linear function. We know that the graph of a linear function in the form of y equals mx plus b will graph as a line because all equations of that form graph as lines. Therefore, if a function can be expressed in the form of y equals mx plus b, the function will graph as a straight line. All right, we'll see you in class.